Let's kick off level 1 with the high explosive shell, HE, the most fundamental and underrated weapon in a tank's entire arsenal, acting as the ultimate delete button for anything not protected by thick armor. And here's the plot twist. Despite what Hollywood tells you, tanks don't spend most of their time dueling other tanks. While most viewers assume tanks exist solely to hunt other tanks, the reality is that HE is the bread and butter for dealing with almost every other threat on the battlefield. Unlike armor-piercing slugs that rely on raw speed and mass, an HE round is essentially a thin steel skin packed to the gills with a massive amount of explosive filler, typically TNT or a high-velocity mixture like RDX. It utilizes a sensitive nose fuse that works like a mechanical hammer sparking a charge. The millisecond it makes contact with a target, it triggers an instant detonation that creates a lethal expanding sphere of blast pressure and jagged shrapnel. Because it has minimal capacity to actually penetrate heavy steel plating, it serves as the definitive battlefield sledgehammer against infantry positions, unarmored trucks, and concrete fortifications. It is simple, brutal, and the essential foundation of firepower used to clear the field before the more specialized tank killers come out to play. Level 2 introduces the Shrapnel Shell, where engineers realized external blast wasn't enough. This round punches through thin armor first, then violently fragments inside, flooding the crew compartment with razor-sharp metal. The key difference? It creates its own shrapnel from the shell casing, not just spalling from the tank's inner wall. Against early war light armor, these were devastating. A solid slug might pass through cleanly, but a fragmenting shell turned the interior into a blender. But as tank armor thickened in World War II, shrapnel shells hit a wall, literally. They couldn't penetrate heavy plating, making them obsolete. This failure pushed engineers toward the time precision of level 3. Forget hoping for a lucky shot. Time fuse rounds turned artillery into a deadly science experiment. Instead of waiting to hit a target, the crew sets an exact time for the shell to explode mid-air, creating a flying bomb that detonates exactly where you want it. This was the secret weapon behind Germany's feared 88mm flak guns in World War II. Imagine bomber formations flying into a pre-programmed wall of shrapnel, exploding at their exact altitude. The numbers tell the story. Traditional shells needed 50,000 rounds to down one aircraft. With timed fuses, just a few hundred shots. Instead of trying to hit a fast-moving target, you're creating a kill zone in the sky and waiting for them to fly into it. This marked the birth of area denial warfare. Proof that being in the right place at the right time beats accuracy every single time. Now we're entering sci-fi territory. Proximity-fused rounds are shells that literally hunt their targets. While timed fuses needed manual calculations, these shells have a built-in radio transmitter that actively scans for enemies as they scream through the air. The moment the sensor detects anything within killing range, a plane, a vehicle, whatever, it automatically detonates and unleashes a sphere of shrapnel that shreds everything nearby. You don't need to hit the target anymore. You just need to get close. Think about how insane this efficiency boost is. Conventional shells needed 50,000 rounds to down one aircraft. Timed fuses brought that down to hundreds, but proximity rounds? One or two shots and it's over. The shell essentially makes its own kill decision mid-flight. The most lethal weapon on the battlefield isn't always the one with perfect aim. Sometimes it's the one smart enough to know when it's close enough to end you. Welcome to level 5, where we ditch the fancy tech and get back to pure, unapologetic violence. The armor-piercing round, or AP. While everything before this relied on explosions and clever timing, AP rounds are the complete opposite. No explosives, no radio transmitters, no fuses. Just a massive chunk of solid metal flying at absolutely insane speeds. This is caveman logic taken to its most sophisticated extreme. If the door won't open, hit it harder. Early in World War II, this was the go-to anti-tank weapon, and the math is brutally simple. Extreme mass plus terrifying velocity equals unstoppable kinetic energy. Because it's one solid piece, it won't shatter on impact like a hollow round would. Here's the twisted genius. It doesn't even need explosives to kill you. The shell slams through the armor and turns the inside of the tank's own hull into a lethal shotgun blast of white-hot metal fragments called spalling. Sometimes the simplest solution is the deadliest one. Level 6 is where tank designers learned a harsh lesson about angles. Basic AP slugs were great at punching through flat armor, but they had one embarrassing weakness. Hit them against sloped plates like those on a Soviet T-34 or German Panther, and they'd just bounce off like a skipping stone. Tank crews were literally watching their shots ricochet into the sky. The fix? Engineers added a soft steel cap to the tip of the hardened penetrator, and here's where it gets genius. This softer metal acts like a grip pad that bites into the angled armor on contact, forcing the round to dig in instead of sliding away. You make part of the shell weaker, so the whole thing becomes deadlier. The enemy's clever sloped armor that was supposed to save them now guides the round straight into their hull. But there's a catch. That blunt cap created massive aerodynamic drag, bleeding off velocity at longer ranges, a fatal flaw that forced engineers back to the drawing board for Level 7. Level 7 is where engineers became obsessed with speed. Meet the armor-piercing ballistic capped round, or APBC, the aerodynamic answer to a crippling design flaw. Remember those capped rounds from Level 6 that could bite into sloped armor? They had one massive problem. Their blunt, flat tips were absolute drag magnets, bleeding off velocity so badly that by the time they reached distant targets, they'd lost most of their killing power. The solution is elegant. Slap a sleek, needle-sharp hollow cone called a ballistic cap on top of the penetrator. This cap has zero interest in punching through armor. Its entire purpose is to cut through air resistance like a hot knife through butter, preserving that critical velocity all the way to impact. Think of it as giving your tank shell a racing spoiler. Suddenly, you're not just hitting hard, you're hitting hard from a mile away without losing punch. This transformed tanks from close-range brawlers into long-range snipers, proving that distance stopped being a defense. Level 8 takes this even further. Level 8 is where it all comes together. The APCBC, the absolute peak of solid slug evolution, and the ultimate why not both solution. Early in the war, tank crews faced an impossible choice. Use a capped round that gripped sloped armor but lost speed over distance, or use a ballistic tipped round that flew fast but bounced off angles. The APCBC said, screw compromise, and combined both technologies into one devastating package. Underneath that sleek exterior sits the soft steel cap from Level 6 that bites into angled armor, but stacked on top is the needle-sharp aerodynamic tip from Level 7 that slices through air resistance and preserves every ounce of muzzle velocity. The result? A shell that hits targets miles away with the same bone-crushing power it had leaving the barrel, then punches through sloped armor and turns the interior into a shrapnel nightmare. By the peak of World War II, this became the undisputed king of tank ammunition, proof that the deadliest weapon is the one that refuses to pick between power and precision. Level 9 is where engineers decided that punching through armor wasn't dramatic enough, so they stuffed a bomb inside the penetrator. The concept is beautifully brutal. Instead of just drilling a hole through the tank, why not have the shell explode inside the crew compartment a split second after penetration? Unlike solid slugs, APHE rounds have a hollowed-out core packed with high explosives and a delayed fuse that triggers right after breaking through the armor plate. In early war combat, this was the ultimate crew killer. One successful penetration meant instant, guaranteed annihilation of everyone inside. But here's where physics crashes the party. As tank armor got thicker, that hollow cavity became a fatal weakness. The shell was now lighter and structurally weaker than solid penetrators, shattering completely against the heavy steel of late-war beasts like the King Tiger. Engineers learned a hard lesson. A fancy internal fireworks show means absolutely nothing if your shell can't even get through the front door. Ambition versus reality, reality won. Level 10 brings us the semi-armor piercing round, SAP, and this is the Goldilocks shell that finally solved the in-between problem. Standard HE shells were too fragile to enter tough targets, and APHE rounds sacrificed too much structural integrity against heavy armor. SAP splits the difference with a massively reinforced nose that's way thicker than a standard shell, giving it just enough strength to punch through light vehicle plating, ship hulls, or concrete bunkers without exploding on the surface. But once that beefed-up tip breaks through the outer skin, the shell's enormous internal cavity, packed with way more explosive filler than any AP round, detonates and absolutely guts the target from the inside. Too tough for a sledgehammer, too soft for a needle, SAP is the perfect answer for everything in between. By perfectly balancing structural integrity with explosive violence, it became the go-to choice for clearing fortifications and shredding light armor, proving that sometimes winning isn't about hitting the hardest or fastest, it's about hitting with exactly the right amount of both. Level 11 is where the anti-tank game changes forever. Meet the armor-piercing composite rigid, or APCR, called HVAP by American crews, and basically the oh crap button for facing heavy armor. Instead of one big chunk of steel, APCR hides a tiny, ultra-dense tungsten core inside a lightweight outer jacket. This clever trick lets the gun accelerate the shell to absolutely insane muzzle velocities, concentrating all that kinetic fury onto a single needle-thin point that punches through armor that laughed off conventional rounds. For crews staring down a King Tiger at close range, this was their lifeline. But physics always demands payment. Because the round is so light, it bleeds energy fast in flight, making it useless for long-range dueling. And since only that tiny core actually enters the tank, you get almost zero internal spalling, meaning you need surgeon-level accuracy to guarantee a kill. shell. Miss the crew or ammunition rack and you've just poked an angry hole. A PCR proved that sometimes the smallest part of the shell is the deadliest, becoming the direct ancestor of the hypersonic dart rounds modern tanks fire today. Level 12 is where we shatter the sound barrier. Meet the armor-piercing discarding sabot, or APDS, the shell that finally broke the speed limits of tank warfare. When the loader slams this round into the breech, it looks like a completely normal full-size shell. But the instant it exits the muzzle, the outer jacket, called the sabot, explosively peels away like a banana skin, falling off in metallic petals and shedding its dead weight in a split second. This is pure engineering brilliance. You're using a massive gun barrel's full explosive power to accelerate a needle-thin penetrator to hypersonic speeds that would be physically impossible for a full-caliber round. Once that sabot falls away, the remaining core, sometimes only half the diameter of the gun that fired it, becomes insanely aerodynamic, with a laser-flat trajectory that makes traditional AP rounds look prehistoric. Distance is no longer a shield. You're now facing a hypersonic sniper round that hits just as hard at 2 miles as it does at 200 meters. A PDS proved that sometimes to hit harder, you first have to learn to let go. Level 13 completely rewrites the rules. Meet the high-explosive anti-tank round, or HEAT, the shell that proved you don't need a massive slug to crack a tank. Everything before this relied on kinetic energy, throwing heavy metal really fast. But HEAT is a chemical energy weapon that carries its own destruction mechanism inside, making the gun itself almost irrelevant. Here's the witchcraft. Inside the shell sits a hollow copper cone backed by a precisely shaped explosive charge. The instant the nose touches armor, the explosive detonates and inverts that copper cone into a hypersonic jet of metal, screaming forward at thousands of meters per second. And here's what everyone gets wrong. It doesn't melt or burn through the armor. It punches through using pure kinetic force at speeds so extreme the steel might as well be butter. But the real cheat code? HEAT doesn't lose penetration power over distance because all the energy is self-contained in the warhead. This shattered the tank monopoly, allowing even cheap shoulder-fired RPGs to threaten multi-million-dollar war machines. The gun became just a delivery system for a needle of hypersonic death. Level 14 fixes a hidden flaw nobody saw coming. Rifling, the thing that makes bullets accurate, actually destroys shaped charges. Here's the brutal irony. While spinning stabilizes conventional projectiles, centrifugal force from rifling spreads the forming metal jet outward like a garden hose, turning your precision armor punching needle into a useless spray pattern. Imagine a laser pointer spinning at thousands of RPMs while you're trying to aim it. That's exactly what was happening to your copper jet. The solution is brilliantly simple. Ditch the spin entirely and stabilize the shell with fins instead. These fins let the round fly straight and stable like an arrow without any rotation whatsoever, something especially critical for the long dart-shaped munitions modern tanks fire. By keeping that internal copper cone perfectly motionless during flight, HEAT-FS guarantees every single joule of chemical energy converts into one focused hypersonic jet on impact instead of spraying uselessly in every direction. This transforms shaped charges from shotguns into surgical lasers, proving that in modern armored warfare, staying perfectly still is the ultimate power move. Level 15 is the ultimate one shell to rule them all. Meet the high-explosive anti-tank multi-purpose round, or HEAT MP, called MPAT in American service. While it still packs that devastating shaped charge from level 13, modern battlefields demanded something more versatile than a shell designed purely for tank duels. Tanks today face everything from infantry and bunkers to drones and low-flying helicopters, and HEAT MP was engineered to handle all of it. This is the true Swiss Army knife of tank ammunition. Instead of forcing crews to gamble on which specialized shell to load during chaotic combat, this single round combines anti-armor penetration with high explosive fragmentation in one package. But the real genius lies in its advanced programmable fuses. With the press of a button, crews switch between point detonation mode for ground targets or proximity fuse mode for aerial threats like helicopters and drones. One shell that adapts to whatever rolls, walks, or flies into view. In modern warfare, the deadliest ammunition isn't always the most specialized. It's the one versatile enough to dominate every single battlefield scenario without breaking a sweat. Level 16 brings the Tandem Charge HEAT round, the definitive double tap of the anti-tank world, engineered specifically to defeat the one defense that nearly rendered standard-shaped charges obsolete: explosive reactive armor, or ERA. For decades, these explosive bricks mounted to the outside of tanks acted like a force field, detonating the instant a HEAT round struck them and disrupting the incoming metal jet before it could ever reach the main main hull, turning your carefully engineered shot into expensive fireworks. The Tandem Round answered with brutal simplicity. Fine, we'll just shoot you twice. By stacking two warheads in the same shell, one directly behind the other, engineers created the perfect counter to reactive armor. The first smaller precursor charge deliberately strikes the ERA brick and triggers its explosion, blasting away the reactive layer like kicking down a door. Then, milliseconds later, before the smoke even clears, the main warhead fires its full-power hypersonic copper jet straight into the now exposed hull as if the armor upgrade never existed. It became the high-tech counterpunch to modern tank survivability, proving that no matter how many protective layers you add, once the outer defense is cleared away, the destruction inside remains absolute. Level 17 is where engineers stop trying to punch through armor and turn the enemy's own hull into the weapon. HESH is packed with plastic explosive that squashes against the target like a wet pancake on impact, then detonates, sending a catastrophic shockwave through the steel that shatters the inner wall into a lethal cloud of high-velocity fragments. The tank looks completely untouched from outside with just a scorch mark, but the crew compartment is an absolute tomb. The twist? HESH requires a rifled barrel to work. The spin spreads that explosive pancake wider for even more devastating shockwaves. That's exactly why British Challenger tanks kept rifled barrels long after everyone else switched. Sometimes the deadliest attack doesn't go through the armor, it turns the armor itself into the murder weapon. We've reached the top, the armor-piercing, fin-stabilized discarding sabot, or APFSDS, universally called the Dart, and the undisputed king of modern tank ammunition. Forget explosives and chemical reactions. APFSDS takes an ultra-dense rod of tungsten or depleted uranium and launches it at hypersonic speeds that make ordinary projectiles look slow. The entire gun's explosive force concentrates onto a needle-thin penetrator, while the lightweight outer sabot peels away in petals the instant it exits the barrel. These penetrators are up to 1,000 millimeters long, too long for rifling without tumbling, so stabilizing fins keep them laser straight like arrow fletching. On impact, the kinetic fury punches through the toughest armor on Earth, gutting the interior with superheated spalling. After a century of evolution, extreme speed and density are the only currencies that truly matter. Level 19 is where tanks become sci-fi. The gun-launched anti-tank guided missile, or ATGM, turning a main gun into a precision sniper platform that hits targets where conventional shells would simply miss. Unlike every round we've covered, ATGMs pack internal guidance systems that actually steer the missile mid-flight toward its target. No manual aim, no ballistic arc, just pure precision. They carry powerful heat warheads that hit with identical lethality at 5 kilometers as they do at point-blank range, because all the energy is self-contained in the warhead. Distance becomes completely irrelevant. There's nowhere on the battlefield to hide. The gun barrel is now just a delivery system for a shot designed to never miss. Secret level, and we're throwing out everything you just learned. After 19 levels of hypersonic darts and guided missiles, you'd expect the ultimate weapon to be a laser or railgun, right? Wrong. It's a giant shotgun shell. The canister round is hundreds of tungsten balls packed into a thin-walled tube. The casing disintegrates the instant it leaves the muzzle, turning your 120mm cannon into the world's most powerful shotgun. Instead of one surgical hole, it creates a massive conical kill zone that clears vegetation, obstacles, and soft targets across a wide area in a single shot. In urban combat, this is the ultimate get-off-me button for a panicking tank crew. The genius? It's literally 19th century grape shot technology in a 21st century tank, proving that sometimes the most effective answer isn't outsmarting the enemy, it's just overwhelming them with raw, devastating volume.